When you write Python scripts for security automation, whether to parse log files, detect anomalies, or interact with network services, bugs are inevitable. Knowing how to debug efficiently is not optional. It is a core professional skill. This chapter introduces two fundamental debugging approaches in Python, using print statements and using the Python debugger, known as PDB. Both have their place, and understanding when to use each one will make you a more effective and autonomous developer. Why debugging matters in security scripting. In previous activities, you built scripts that read log files, counted error lines, handled exceptions with try/except blocks, and created interactive menus. As your scripts grow in complexity, errors become harder to spot just by reading the code. A script that silently produces wrong results is sometimes more dangerous than one that crashes immediately, especially in a security context. Imagine a script that is supposed to flag suspicious login attempts but silently skips certain lines because of a logic error. You would never know. Good debugging habits prevent these silent failures. The print-based debugging approach. The simplest and most immediate debugging technique is inserting print calls into your code to display the value of variables at key moments during execution. This is often called print debugging or printf debugging. You have almost certainly done this already without thinking of it as a formal technique. Here is how it works in practice. Suppose you wrote a function to count the number of lines containing the word error in a log file. Def count _ errors file path. Total equals 0. With open file path, r, as f. For line in f. If error in line. Total plus equals 1. Return total. If the result seems wrong, you can add print statements to inspect what is happening. Def count _ errors file path. Total equals 0. With open file path, r, as f. For line in f. Print processing line, line.strip. If error in line. Print found error in this line. Total plus equals 1. Print final total. Total. Return total. This lets you see exactly which lines are processed and whether the condition triggers correctly. You might discover, for example, that your log file uses lowercase error instead of uppercase error, which would explain why the count is 0. Advantages of print debugging. It requires no setup and no additional knowledge beyond what you already know. It works in any environment, local terminal, remote server, simple scripts. It is very fast to add and remove. It is immediately readable even by someone who does not know Python well. Limitations of print debugging. As scripts grow longer, print statements can accumulate and clutter the output, making it hard to focus on the relevant information. You must manually add and remove them each time you debug, which is error-prone. It is easy to forget a print statement and accidentally leave it in production code. You cannot pause execution, inspect the state of all variables simultaneously, or step through the code line by line. For complex bugs involving loops, nested function calls, or conditional branches, print debugging can quickly become insufficient. In security automation, you will often work with scripts that interact with files, external tools, or network data. When a bug occurs deep inside a chain of function calls, print statements alone may not give you enough context. Introduction to PDB, the Python debugger. PDB is the built-in interactive debugger included with Python. It allows you to pause the execution of your script at any point, inspect the current state of all variables, execute code line by line, and even modify variable values on the fly. Think of it as being able to freeze time inside your script and look around. You do not need to install anything to use PDB. It is part of the Python standard library. How to activate PDB? The most direct way to use PDB is to insert the following line anywhere in your script where you want execution to pause. Import PDB, pdb.set_trace. When Python reaches this line, it stops and opens an interactive prompt inside the terminal. From this prompt, you can type commands to inspect and control the execution. In Python version 3.7 and later, there is an even simpler built-in shortcut. Breakpoint. This single line does exactly the same thing as the import and set_trace combination above. It is the recommended modern way to activate PDB. Example of PDB in action. Let us take the same error counting function and add a breakpoint. Def count _ errors file path. Total equals 0. With open file path, r, as f. For line in f. Breakpoint. If error in line. Total plus equals 1. Return total. When you run this script, execution will pause at the breakpoint line during the first iteration of the loop. You will see a prompt like this. Greater than if error in line. PDB. From this prompt, you can type commands. Key PDB commands you must know. N. Next. Execute the current line and move to the next line. Does not step into function calls. S. Step. Execute the current line and step into any function call on that line. C. Continue. Resume normal execution until the next breakpoint or until the script ends. Q. Quit. Immediately stop the debugger and terminate the script. P. Variable_name, print, display the current value of a variable. For example, typing P line will show you the content of the variable line at that exact moment. PP variable_name, pretty print, same as P but formats complex objects like dictionaries or lists more readably. L. List, show the surrounding lines of source code around the current position, so you know where you are in the file. B. Line_number, break, set a new breakpoint at a specific line number without modifying the source code. H. Help, display a list of all available commands. When to use print versus PDB. Use print debugging when the bug is simple and localized. For example, a variable has an unexpected value in one specific place. You are working quickly on a short script and do not want to switch mental context. You want to keep a trace of execution over time, for example, logging which lines were processed. Use PDB when the bug is subtle and involves multiple variables or function calls interacting in unexpected ways. You need to understand the exact flow of execution through a loop or a chain of functions. You want to test hypotheses interactively without restarting the script each time. The script crashes with an exception and you cannot tell from the traceback alone what state the program was in. In a professional security context, you will often deal with scripts that process large volumes of data, log files with thousands of lines, network scan results, API responses. In these cases, PDB is far more powerful because it lets you pause at the exact moment of the problem and inspect everything around it. A practical debugging workflow. Here is a recommended workflow when you encounter a bug in your script. 1. Read the error message and trace back carefully. Python tells you the file name, the line number, and the type of exception. This is your first clue. Identify the suspicious area of code. Based on the traceback and your understanding of the script, narrow down where the problem might be. 3. Add a breakpoint, or a few targeted print statements, just before the suspicious area. 4. Run the script and observe the output. If using PDB, use P to inspect variables and in two-step forward pot. 5. Once you understand the cause, fix the code. 6. Remove all debugging statements, breakpoint calls and print statements used only for debugging, before considering the script ready. Important, never leave debugging statements in production code. In security tools, leaving debugging output in production scripts is a risk. Print statements can leak sensitive information, for example, file paths, credentials read from configuration files, or internal data structures, into terminal logs or log files that might be accessible to others. Similarly, a breakpoint left in a script that runs automatically, for example, as a scheduled task, will cause the script to freeze indefinitely, waiting for interactive input that will never come. Always clean up your debugging statements before deploying a script. Connection with exception handling. You have already learned about try/except blocks for handling errors gracefully. Debugging and exception handling work together but serve different purposes. Exception handling is designed for errors that you anticipate and want to manage during normal operation. For example, a file that might not exist. Debugging is for errors that are unexpected and that you need to understand and fix. When an exception occurs during debugging, PDB can be invoked automatically using the command python mpdb_script.py, which launches the debugger at the start of the script. If the script crashes, PDB will activate automatically at the crash point, allowing you to inspect the state at the moment of failure. Summary of key points. Print is simple, immediate, and effective for quick checks, but clutters code and is limited for complex bugs. PDB is the built-in Python debugger. Activated with breakpoint or import PDB, pdb.set_trace. The essential PDB commands are N, next line, S, step into function, C, continue, Q, quit, P, print, variable, L, list code, B, set breakpoint, H, help. Use print for simple, localized bugs. Use PDB for complex, multi-step bugs where you need to inspect program state interactively. Always remove debugging statements before deploying or sharing your script, especially in a security context where output might expose sensitive data. A good debugging workflow is: read the traceback, identify the suspicious area, insert a breakpoint, inspect variables, fix the bug, clean up. With these tools and habits, you are equipped to tackle the inevitable bugs that arise when writing real-world security automation scripts.